but you can build 2 Tier 2 facilities and have better redundancy because you have geographic diversity than you can build 1 Tier 4. It's about 1/3 of the cost. So I think we're going to start seeing a change in metrics of how green we are based to our level of redundancy. This is a death by PowerPoint slide, so if you're not already dead just by looking at it, you'll notice that I was kind enough to highlight the changes in 942A in red. But if anybody wants a copy of this presentation, I'm happy to share a PDF with you. I just want to make sure that you caught the highlights. So, Category 3 and 5E are no longer acceptable in a data center with the exception of voice backbone. OM4 will be the recommended fiber. LC is the recommended 2-pair connector, and MTP and MPO for multi-strand connectors. And then all of the 568Bs are now the 568Cs. Those have all been incorporated. So if we look at specifically the layout, you notice we've got our main distribution area, which is our core, that feeds to our horizontal distribution areas, which is where we see our LAN switches, that type of stuff. And that goes out to our equipment distribution areas where we typically see our servers. Top of rack, as you hear all this talk about, is allowed as an exception only because it's considered point-to-point connections, which are allowed as an exception. The same thing that happens in ISO. You'll notice we have very much the same terminology, very much the same layout. Point-to-point is allowed as an exception only and must be in close proximity. And the reason for that is really simple. You can go in a lot of data centers, and if you see all these point-to-point connections, there's no structured system. In a structured system, we have patch panels, so you always know where the other end is because we have standards for that. Point to point, you never know. I did an audit not long ago, and I do a lot of data center audits. Some of them are pretty hilarious, actually. If you think your data center is bad, I can assure you I've seen worse. But I picked up all these floor tiles, and underneath, right in front of the 6-pack of beer for the night crew, there was all these little bundles of cable that said Unix Row 1, Cabinet 1. And I said, well, where is that? They said, we don't know. We quit using Unix like 10 years ago, and nobody still works here that worked here then. Had that been on a structured system, it would have been labeled with the other side, and you would have known. It's very hard to get rid of old abandoned cable, which is a code requirement in the US, if you don't know where the stuff goes. So, if we talk about delivering 10 gigs specifically, if you want to know where Intel and Cisco and some of the rest of the guys are, we had an expert panel with them. You might recognize the little blonde-haired chick over there on your left. But anyway, 10G-based T will be launched native on motherboards and all of the Intel motherboards that are shipping starting this quarter. Cisco has committed to fully supporting 10G-based T through their entire Nexus product line. It's already available in several of the Catalyst models throughout the end of this year, first quarter of next year. So that technology is out there and it's viable. It was very high power to start with, but the chips have come down now where it's actually really worth looking at. So from an Intel perspective, it's less than half a watt per port. If you get down to short reach mode, it knocks about 1.5 watts off of that. And then when energy efficient Ethernet hits, it'll actually be a little less per port than its fiber counterpart. And Intel, this is their slide, fully expects 10G-based T to take over about half of this top of rack market. So when we talk about using a structured system, we want to make sure we don't end up with the spaghetti, we don't end up with the problems, that we have something. If you're in any compliance-related industry, you have to be documented anyway. How do you do that when you have a bunch of point-to-point spaghetti running all over the data center? It's pretty much impossible. So it allows us to take care of that. Cable abatement is very easy, or getting rid of old abandoned cable because we know what's gone. If we look at that top of rack technology, though, we are limited to 1, 3, and 5 meters on a twin-ax cable with a switch that's supposed to be in the top of each and every server cabinet. You can do 7 meters actually with active optical, or you'll hear the term middle of row, end of row. But let's look at what it really looks like. So these are the cable assemblies. You'll notice they're not RJ45 like we're used to. It is a little bit different assembly. We actually sell these too, but there's several different brands out there. In most cases, this comes with a networking purchase though, so you don't really see that. It looks like a savings on cable, even though technically you're buying a cable. But if we do top of rack like they want us to do, we put a switch in the top of each and every server cabinet. Now, if I have 42 rack units available in a server cabinet, how many servers can I put in that cabinet? It depends, right? It depends on how much power and how much cooling I'm supplying to each and every cabinet. Internationally, that average is 5.5 to 6 kilowatts, which puts about 14 servers in each and every cabinet. So if I put a 48-port switch in there, and assuming I'm being very, very frugal, and I'm going to VLAN my primary network and secondary network, I have 20 spare ports in each one of those. Not the best from an energy efficiency standpoint. Also, if we look at the server network card, which is things people forget to, the network guy says, well, yeah, you know, we're putting this technology because it's half a watt a port, and then you realize that the server network interface card is about 15 to 20 watts a port, then you're not really doing yourselves any favors. Now, if we do end of row, or really technically it's called in-row patching, we put the switch out there in the row, and we dedicate that switch to an entire row of server cabinets. This means my oversubscribed ports goes down, because now I've opened it up to a whole bank of server cabinets as opposed to a single server cabinet. Or we can do what's called any to all, and this is what you'll notice from the diagrams and the standards. So what we have, we can either do that 3 connector where you plug directly into a switch, and then that's, and then that's mirrored out to a patching zone somewhere out there. You can have multiple patching zones. Or you can do what's called 4 connector, which is the most popular, where we actually put patch panels in the switch cabinet. And the reason for that is because we end up with a lot of density, whether we do a stack of 2,000, you know, of small switches, or we do a giant switch. Women have this trick. When we get pregnant, you can wrap a rubber band through your belt loop and hook the other one around your button. You guys can try it at Thanksgiving. It actually works. But it allows your pants to expand. I did an audit not long ago, and every single switch cabinet in this data center had the Prager's trick on the door, because there was no way to close the switch door cabinets. So if we do it this way, this cabinet doesn't change. All the moves, adds, and changes happen over in our patching zone. So we do this, what we have, one of these should be a laser, right?
Top.
Nope, top?
Mm-hmm.
Oh, there we go. So we have patch panels here that are mirrored over here in our patching zone, and then this goes to a whole bank of server cabinets. So that allows any server to connect to any switch port within that zone. So now we can manage that oversubscription of ports and make sure that we use all that we're paying for. If we do any to all like this, that means that we have 48 ports of copper. How much does that copper cost me after I run it? Nothing, right? I pay for it once. I can use that for monitoring, KVM, ILO, any connection that I want to when it's out there, or obviously for a network switch connection. And I use and then I have the chassis-based switches, which have far more energy-efficient power supplies. If I do top of rack, I add 2 power supplies to each and every cabinet, which takes away from the number of switches I can put in there because it eats up some of my kilowatt load. And on average, I'm going to use about 28 of those ports, and I'll have 20 spare ports in each and every cabinet. That's assuming primary network and secondary network are in the same switch. If you double that up, it's even worse. If you start using some of those for KVM, ILO, all that kind of stuff, in a lot of cases what you end up with is an extra 48 port switch thrown in there that you're using 2 or 3 ports of, and you got 40 some odd ports of vacant capacity. So if we just compare those over 20 cabinets, if I do top of rack or point to point, as it's called in the standards, I add 40 power supplies, I pay for 960 ports, and on average there's about 400 ports I can't use. If I do the central any to all, I have 4 chassis, more energy efficient based power supplies. I pay for 576 ports, and there's 16 ports that I can't use. Now you think about cloud computing and infrastructure as a service, software as a service. A lot of the colos that I work with now actually lease out managed ports as part of their portfolio because they figured out from a power consumption standpoint, it's a lot more energy efficient for them because at the end of the day, they get the power bill. And a lot of places they can't rebuild for power because state laws don't allow them to do that. The other thing is, if I have that cabling system, I have this highway, this nice nifty little highway where I can start putting equipment where it makes the most sense for power and cooling. We think about coordinating this with facilities. If I buy a bunch of blade servers and the only place I have open network ports is in that spot, that's probably not where I want to put them. In a lot of cases, you can save money on your facilities by staggering your hottest equipment around that area as opposed to putting them in one. If you know you don't have capacity, it makes sense to build a high density area and provide supplemental cooling to that area instead of trying to beef up, cooling in the whole data center. So this is, since I wrote that white paper, this is from one of the customers that I work with up in Canada, and they were doing gigabit, which has always been a 100-meter connection, and they got sold into this whole top of rack. And they were putting in about 336 cabinets, and they had 40 rack units available for servers. And the networking guy said, but I'm going to save you $275,000 on your cabling. Sounds pretty good, right? We'd all like to go to our boss and say, hey man, I just saved you $275,000. So I said, well, let's look at this though. Assuming that you could put 40 servers in all those cabinets, you're still going to have 8 spare ports on each switch because they were going to put 2 switches in every cabinet. And we add all that up, they would have ended up with 56 spare switches, entire switches, that they would have bought, paid for, paid to power, even in idle mode, and paid that wonderful active maintenance on year over year for each and every network. And combined over about 3 years, that would have been a cost of $1,119,000. And they said, but wait, we can't put that many servers in there. We don't have that capacity. They were going to end up with about 12 servers per cabinet, which means they would have had 12,096 spare ports per network, or they would have purchased 504 unnecessary switches completely. And the cost of those switches and the maintenance over 3 years was almost $2.2 million, all to save $275,000. Kind of like your wife saying, I'm going to save a ton on grocery bills, and then you find out you're going out to eat at Starbucks, you're going to buy breakfast, you're going to buy lunch, you're going to buy dinner, because that's out of the entertainment budget. It doesn't really matter. So the point is, we need to really start balancing all of these different purchases and looking at the data center like one big ecosystem. If we look at the cost of these top-of-rack cable assemblies compared to a 30-meter assembly of structured cabling, you can see it's significantly more expensive. The one at the top carries a 90-day warranty because there's an interconnect assembly attached to it. The one down here at the bottom has a 20-year warranty because it's a structured system. This is kind of how it looks like if you look at it. So we've got server cabinets, we've got primary network, secondary network. In this particular data center, they're at the end of the row just because they're on different fire suppression zones, but you can't have one whole row of primary, one whole row of secondary, and then it comes down here into this distribution zone. So I can connect any of these server cabinets to primary or secondary. If I add a few more servers and I don't have the capacity or networking doesn't have a budget to buy another switch, I can actually come over here and borrow switch ports off the adjacent zone until I build up enough need to buy another switch. A couple other things that are changing when you talk about 10 gig out on the horizontal, we have to figure out how to bump up the backbone. So this has changed a little bit on the fiber side. If you'll notice when we get to 40 and 100 gig, currently as the standards are, we're at 8 strands for 40 gig and 20 strands for 100 gig. And this is how it looks like. For 40 gig, we have a regular 12-strand assembly, so you have 4 that transmit, 4 that receive, because we're doing parallel processing here. And then if you look at 100 gig, as it stands right now, we have 10 that transmit, 10 that receive. The thing that is changing is right now there is a current project in IEEE to make 100 gig also work over 8 strands. So before you go crazy planning in too many strands, that change is happening. So still 2 strands on multi-mode though. Other than that, I have 30 minutes to cram in as much as I could. Any questions? Well, or I guess there'll be a panel after.
That's right. We can discuss questions.
All right. Thank you.